Today's lesson is about derivatives of logs. You need to have gone through the note cards for this, as well as reviewed your log properties from Algebra 2 in order to be ready for this lesson. So let's start with an easy one. Example 1, f of x is equal to x times the natural log of x. So to take the derivative of this, we're going to use the product rule, where x is the first function and natural log of x is the second function. So we'll go first function x times the derivative of the second function, which is 1 over x, plus the second function, natural log of x, times the derivative of the first function, 1. And then we just simplify this. X times 1 over x is 1, and natural log of x times 1 is just natural log of x. And that's the answer. Okay, number 2. G of x equals natural log of x over x. So this one is very similar to number 1, except for instead of using the product rule, we're going to use the quotient rule. So, g prime of x is equal to the bottom function, which is x, times the derivative of the top function, 1 over x, minus the top function, natural log of x, times the derivative of the bottom function, 1, all divided by the bottom function squared. And then we simplify this to get 1 minus natural log of x over x squared. And that's the answer. Alright, number 3, we're going to do f of x is equal to the natural log of x squared plus 1. And on this one, we're going to use the chain rule. So we're going to say, take the derivative of the outside function, copy the inside function, multiply by the derivative of the inside function. So the outside function is the natural log of x. What is the derivative of the natural log of x? 1 over x. Except for we're going to replace the inside function where the x would be. And then we're going to multiply by the derivative of that inside function, which is 2x. So this ends up being 2x over x squared plus 1. As a shortcut, you don't have to show this middle step. Anytime you have the natural log with a function on the inside here, you can just put the derivative of that inside function on the top over that function on the bottom. That's kind of shortcutting it, but that's the way it's always going to work with this chain rule in our log function. Alright, example 4. We're going to do y equals the natural log of x squared plus 1 times x cubed plus 2 to the 6th power in parentheses. Now, you can do this one the way that we did the last one, using the chain rule, where you'd put the derivative of the the derivative of this inside function on the top over the original inside function on the bottom. However, if you look at this inside function, it's kind of complicated because it has a product and this power on here. There's actually an easier shortcut way to do this with logs. And the way that we do this is we're going to use our algebra log properties to expand this log before we take the derivative, and then the derivative becomes way easier to do. So let me show you how that works. We're not taking the derivative yet, we're just rewriting this function using our log properties. So, if you'll remember, when you take the log of a product, you can split that into two separate logs by adding them together. And you can take that power and put it out in front. Again, you're going to need to review your log properties from Algebra 2 to make sure that you're prepared for these, because these expanding the logs makes these problems a lot easier. Okay, so now instead of having to take the derivative of that whole inside function, we have much easier functions to take the derivative of. So I'm going to say the derivative of y with respect to x is equal to, now I'm going to use that little shortcut. What is the derivative of my inside function, x squared plus 1? Well, that's 2x. Over, we're just going to put the original inside function, x squared plus 1. And now we're going to say, what is the derivative of this inside function? Well, that's 3x. I'm going to go ahead and multiply that times 6 on the top, because that's like a 6 over 1. So 3x times 6 would give me, 3x squared, 3x squared times 6 would be 18x squared on top, and then x cubed plus 2 on the bottom. And now, essentially we're done taking the derivative. However, if you checked your answer in the back of the book, you're not going to find this, because they're going to consider it more simplified if these fractions are actually combined with each other. So they would multiply this first fraction times x cubed plus 2 over x cubed plus 2, that's a clever form of 1, and then this one, x squared plus 1 over x squared plus 1, and what this does is it allows us to have a common denominator. So the bottom would be x squared plus 1 times x cubed plus 2, and then on the top I'm going to distribute that 2x to both of those terms to get 2x to the 4th plus 4x, and then I'm going to distribute this 18x squared to both of those terms to get 18x to the 4th plus 18x squared. Combine my like terms, that's going to be 20x to the 4th plus 18x squared plus 4x, all over that common denominator. And you could FOIL that out, but generally it won't be FOILed out. It's just simplified either way. So this problem is a lot easier using your Algebra 2 log properties. However, you'll get the same result if you try to do it without it. Just be a little bit nastier arithmetic for you. Okay, that was example 4. Let's take a look at example 5. G of x equals the natural log of x squared times e to the negative x squared power. Alright, if I were you, I would pause this video lesson, try this one on your own, and then come back and check to see if you get it right. This is another problem where it would be a good idea to expand it to make it easier before you begin taking the derivative. So I have a log of a product. I can change that into two separate logs, the natural log of x squared plus the natural log of e to the negative x squared power. Now, this can be simplified a little further. The base on this log is e, and the base on this power is e. So if you'll remember from Algebra 2, you can simplify that to just negative x squared, because the natural log base e of the base e undo each other and result in just the power that's on the e, because they're inverse operations of each other. So now I'm going to take the derivative. G prime of x will equal, my inside function here is x squared. What is the derivative of x squared? Well, it's 2x divided by the original function x squared. The original inside function, I should say. And then what is the derivative of negative x squared? That's just negative 2x. This first term simplifies, the x's divide out, so I have 2 over x minus 2x, and that is the answer. Alright, number 6, y equals natural log of x plus 4 over x minus 3. Again, pause the video, try it on your own, see if you get the right answer. This one is one where we're going to expand it using our Algebra 2 log properties, but this time, since it's a quotient, we're going to expand it. When we expand it, it will be a difference of two logarithms. So the natural log of x plus 4 minus the natural log of x minus 3. And so let's take the derivative. What's the derivative of the inside function here? It's just 1 over the inside function. Minus, what's the derivative of this inside function? It's 1 over the inside function. Technically, you've taken the derivative at this point, but you won't find this answer in the back of the book. They're going to get a common denominator. So, and put the fractions together, this will be times x minus 3 over x minus 3. And this will be times x plus 4 over x plus 4. Oops, that doesn't look like an x. So, this will be x minus 3 over, we can leave this in factored form, minus x plus 4 over that common denominator. Now this negative will distribute to both terms in the parentheses here. So you should have x minus 3 minus x minus 4 over the common denominator. Those x's simplify to 0. You'll have a negative 7 on top over this common denominator. That's the answer. Okay, now the next problems that we're going to do are a little bit different. For example, we're going to learn a new method called logarithmic differentiation. This is a little bit different from what we were just doing because we are going to be taking derivatives with logs like we were before, but the problem's not going to start with any logs. We'll start with something like y equals x to the x power. Now, how do you take the derivative of y equals x to the x power? It's kind of strange. Well, it's actually a lot easier to do if we introduce logs into the problem. There are no logs to start, however logs can make this problem easier. So the first step for logarithmic differentiation is just to take the natural log of both sides. So natural log of y equals natural log of x to the x power. Now, the next step is I want to find dy dx, so I'm going to use implicit differentiation. So, this first term, natural log of y, if I take the derivative of that, it'll be 1 over y, but since I'm taking the derivative with respect to x, a different variable than y, I multiply by dy dx. And over here, I can kick the x power here out in front, which means this would be the same thing as x natural log of x. And we actually did that before, earlier. It might have even been our first example. It sure was. So we use the product rule to take the derivative of that. So it's x times 1 over x plus natural log of x times 1. So we have 1 over y dy dx equals 1 plus natural log of x. Now, I want to isolate dy dx, so I'm going to multiply both sides times y over 1 times y over 1. But I don't want to have my dy dx in terms of both x and y. I only want x's. So I'm going to take out this y, and I'm going to replace it with what I know y to be equal to, which is x to the x power. So it'll be 1 plus natural log of x times, instead of y, x to the x power. And that's the answer. Let's try another one of these. Number 8. Y equals the 5th root of x minus 1 over x plus 1. So, this is like a chain rule with a quotient rule inside of it. Big, gnarly mess. A much easier way to do this is using logarithmic differentiation again. And in the directions, it's going to tell you to use logarithmic differentiation most of the time. However, as we go along further in the course, you're just going to have to go, this would be easier if I use logarithmic differentiation, and have that as one of your tricks in your tool bag to pull out to make a problem simpler for yourself. But the first step is going to be to take the natural log on both sides. And now I want to use my log properties to expand this log on the right side. So I can think of this as the natural log of x minus 1 over x plus 1 to the 1/5 power. That's the same thing as the 5th root. And that power can come out in front. So I'll have natural log of y equals 1/5 times the natural log of x minus 1 over x plus 1. And now, since that's a quotient, I can split that into two separate logs with a difference in between them using my algebra log properties. So this would be 1/5 natural log of x minus 1 minus 1/5 natural log of x plus 1. Now, notice I haven't done any calculus yet. All I've done is algebra. Now I'm ready to do my calculus. It's much easier to take the derivative now. The derivative of the natural log of y with respect to x is 1 over y dy dx. Now I've got the 1/5 times the derivative of the inside function is 1 over the x minus 1, and then minus 1/5 times the derivative of the inside function is 1 over x plus 1. Alright, so I'm going to go ahead and distribute the 5s on the bottom here. It should be in parentheses. So I'm coming over here. 1 over y dy dx equals 1 over 5x minus 5 minus 1 over 5x plus 5. I want to multiply by y on both sides, so I have dy dx by itself. And I don't want to leave it with a y in it, so I want to replace that y with what I know y is equal to, and say dy dx equals the 5th root of x minus 1 over x plus 1 times this which I had in the parentheses. Oops, I missed my 5 on my parentheses there. And that's the answer. We're done with that one. Okay, last example. Number 9. Again, we're going to, oh wait, no. This one is not a logarithmic differentiation problem. Y equals log log of 1 minus the sine squared of x. So we've been using natural log a lot, but in today's note cards you also have one for the log log. It actually doesn't come up that often. We usually stick with natural logs in calculus, but you could see this, especially on a multiple choice kind of question on the AP Calculus exam. The first thing I would do is simplify this equation so that it's easier to integrate. You might remember from pre-cal that 1 minus the sine squared of x is a Pythagorean identity, and it is equal to the cosine squared of x. So that simplifies this problem. Now we're going to take the derivative. So the derivative of y with respect to x is equal to, this is going to be 1 over my inside function, which is cosine squared of x, and then multiply by the natural log of 10. This is, the 10 comes from the base on this log. If you'll remember, your common log always is considered to be a base 10. We don't go around writing that on all of our common logs, but it is always there. And this step actually could be considered to be there on a regular natural log. It's just when you do the natural log of e, it equals 1, so it kind of cancels out because it's an inverse operation. Okay, so we're still using the chain rule, so times the derivative of the inside function cosine squared of x. So, dy dx is equal to, now, what is the derivative of the cosine squared of x? Well, you can do the chain rule here. The outside function is that second power, so I would bring that out in front, copy the inside function, which is cosine of x, and then multiply by the derivative of the inside function. The derivative of the cosine is the sine of x. That's from thinking about this as cosine x squared, which means the same thing as cosine squared of x. That's just a shorthand for it. And now the bottom is cosine squared of x times natural log of 10. Notice we have some cancellation going on here. The cosine of x on the top divides out with that square power, just leaving us one cosine on the bottom. So I have dy dx equals 2 sine x over cosine x natural log of 10. Now, what is the sine over the cosine from pre-cal? Well, that equals the tangent. So 2 times the tangent of x over the natural log of, 10 is the simplified answer here. Alright, good luck with your taking derivatives of logs and using logarithmic differentiation.